Download this code from codegive.com, link in the description below. OK, let's dive into SQL Server development best practices. This is a comprehensive guide, and since part 1 implies a lot to cover, we'll focus on key areas essential for writing efficient, maintainable, and secure SQL Server code. Part 1, Foundations of SQL Server Development Best Practices. This first part will cover 1. Naming conventions and standards. 2. Data types and lengths. 3. Indexing strategies. 4. Stored procedures and parameterization. 5. Error handling and logging. 6. Code formatting and comments. 7. Transaction management. Let's get started. 1. Naming conventions and standards. Why they matter. Consistent naming makes your code easier to read, understand, and maintain. It eliminates ambiguity and helps you quickly identify the purpose of different database objects. General principles. Descriptive names should clearly indicate the object's purpose. Consistent. Use a consistent style throughout your database. Concise. Keep names reasonably short while remaining descriptive. Avoid reserved words. Don't use SQL Server reserved words as object names, example user, order, group. If you must, surround the name with brackets, user. Case sensitivity. SQL Server is generally case insensitive for object names, but it's good practice to choose a case convention, example Pascal case, snake_case, and stick to it. Consistency is key. Prefixes/suffixes. Use prefixes or suffixes to denote object types. Examples. Object type prefix/suffix. Example: table TBL customers, TBL order details. View VW customer orders, VW product summary. Stored procedure SP get customer by ID, SP update order. Function FN calculate age, FN format date. Trigger TRG order insert, TRG product update. Index 9 customers last name, 9 order details order it producted. Constraint, PK customers. Constraint, FK orders customerid. Constraint, unique, UQ customers email. Constraint, check, CK products price. Column, none or short abbreviation related to purpose, customer ID, first name, order date, unit price. User-defined data type UD email address, UD phone number. Code example, table creation. Explanation TBL customers, TBL orders, TBL order details, tables are prefixed with TBL. Customer ID, first name, order date, column names are descriptive and use Pascal case. PK customers, FK orders customerid, constraints use PK and FK prefixes. Identity, 1,1, used for auto-incrementing primary keys. 2. Data types and lengths. Why they matter. Choosing the correct data type and length optimizes storage, improves performance, and prevents data integrity issues. Incorrect choices can lead to wasted space, data truncation, and unexpected errors. Principles. Use the smallest appropriate type. Don't use varchar, max, if varchar, 255, is sufficient. The max types store data off-row, impacting performance. Asterisk consider data ranges asterisk use int, bigint, smallint, or tiniint based on the expected range of values. Asterisk precision and scale for numeric data asterisk use decimal or numeric for monetary values to avoid floating point rounding errors. Specify the appropriate precision and scale. Asterisk date and time data asterisk use date, time, date time to, or data timey offset as needed. Date time to generally provides better precision and a wider range than date time. Asterisk Unicode support asterisk use and varchar and nchar for strings that may contain Unicode characters, example characters from different languages. Asterisk avoid implicit conversions asterisk write queries that explicitly match data types to avoid performance penalties due to implicit conversions. Asterisk examples asterisk. Data type use case example. Int whole numbers, example customer IDs, customer ID int. Bigint large whole numbers, example counts, record count bigint. Smallint small whole numbers quantity smallint. Tiniint very small whole numbers, 0 to 255, status code tiniint. Decimal, 10, 2, monetary values price decimal, 10, 2. Varchar, 255, variable length strings, up to 255, first name varchar, 255. And varchar, 100, Unicode variable length strings, up to 100, product name and varchar, 100. Date dates only order date date. Date time to dates and times with high precision order date time to. Bit Boolean values, 0 or 1, is active bit. Asterisk code example asterisk. Explanation asterisk. Asterisk and varchar, 100, is used for product name to support international characters. Asterisk decimal, 10, 2, ensures accurate storage of unit price. Asterisk smallint is sufficient for units in stock because the quantity is expected to be small. Asterisk discontinued is a bit because it represents a Boolean value. 3. Indexing strategies. Asterisk why they matter asterisk indexes are crucial for speeding up data retrieval. Without proper indexing, queries can perform full table scans, which are very slow, especially on large tables. However, indexes come at a cost, they consume storage space and can slow down write operations, inserts, updates, deletes. It's about finding the right balance. Asterisk principles asterisk. Asterisk index columns used in where clauses asterisk create indexes on columns that are frequently used in where clauses, join conditions, and order by clauses. Asterisk clustered index asterisk every table should have a clustered index. This index determines the physical order of the data on disk. Usually, the primary key is the clustered index, but not always. Choose a clustered index that is narrow, small size, unique, and rarely changes. Asterisk non-clustered indexes asterisk create non-clustered indexes on other columns that are frequently queried. A table can have multiple non-clustered indexes. Asterisk composite indexes asterisk create composite indexes, indexes on multiple columns, when queries frequently filter or sort by multiple columns. The order of columns in a composite index is important. Place the most frequently used column first. Asterisk covering indexes asterisk a covering index is a non-clustered index that includes all the columns needed to satisfy a query. This allows the query to retrieve all the data from the index without having to access the table, which can significantly improve performance. Asterisk consider index maintenance asterisk indexes need to be maintained as data changes. Over-indexing can slow down write operations. Regularly review and rebuild or reorganize indexes. Use the Database Engine Tuning Advisor. SQL Server provides a tool called the Database Engine Tuning Advisor, DTA, that can analyze your workload and recommend indexes. Types of indexes. Clustered index. Determines the physical order of data. 1 per table. Non-clustered index. A separate structure that points to the data. Multiple per table. Unique index. Ensures that the indexed column, S, contain unique values. Filtered index. An index that only includes a subset of rows based on a filter condition. Useful for tables with sparse data. Code example. Explanation. 9 customers last name, an index on the last name column, which is likely used in where clauses to search for customers. 9 customers last name first name, a composite index on last name and first name. Queries that filter by both columns will benefit from this index. The order of columns matters. If queries usually filter by last name first, it should be the first column in the index. 9 order details order it includes a covering index. If a query needs only order ID, product ID, quantity, and unit price, SQL Server can retrieve all that data directly from this index without accessing the base table. The include clause adds the extra columns to the leaf level of the index. 4. Stored procedures and parameterization. Why they matter. Stored procedures are precompiled SQL code stored on the server. They offer several benefits. Performance. Stored procedures are parsed and optimized when they are created, so they execute faster than ad hoc SQL statements. Security. You can grant permissions to execute stored procedures without granting direct access to the underlying tables. Maintainability. Changes to the database schema or logic can be made in the stored procedure without affecting client applications. Reduced network traffic. Only the stored procedure name and parameters need to be sent across the network, reducing network traffic. Code reusability. Stored procedures can be called from multiple applications or other stored procedures. Parameterization. Always use parameterized queries to prevent SQL injection vulnerabilities. SQL injection occurs when malicious code is inserted into a query through user input. Principles. Use stored procedures for common operations. Encapsulate frequently used SQL code in stored procedures. Parameterize queries. Always use parameters to pass values to stored procedures. Input validation. Validate input parameters in the stored procedure to prevent errors and security issues. Return values. Use return values to indicate success or failure of the stored procedure. Use set no count on. This prevents SQL Server from returning the number of rows affected by each statement in the stored procedure, which can improve performance, especially when the procedure contains multiple statements. Transaction management. Wrap multiple DML operations within a transaction for atomicity. Code example. Explanation. SP get customer by ID, a simple stored procedure that retrieves customer data based on customer ID. SP update customer, a more complex stored procedure that updates customer information. Set no count on, improves performance by suppressing the row count messages. Begin transaction, commit transaction, rollback transaction, ensures atomicity of the update operation. Begin try, begin catch, handles errors gracefully. Rise error or throw, raises an error message if an error occurs. Asterisk parameterization, the use of @customer ID, @first-name, etc., prevents SQL injection. 5. Error handling and logging. Why they matter. Robust error handling is essential for preventing application crashes and providing meaningful information to users and administrators. Logging provides a record of events that can be used for troubleshooting, auditing, and performance analysis. Principles. Use try, catch blocks. Wrap code that might throw exceptions in try, catch blocks. Log errors. Log errors to a table or file. Include relevant information such as the error message, error number, stored procedure name, parameters, and timestamp. Handle transactions correctly. If an error occurs within a transaction, roll back the transaction to maintain data consistency. Raise meaningful errors. Use raise error or throw to raise custom error messages that provide context and guidance. Avoid masking errors. Don't catch exceptions and do nothing. Always handle errors or rethrow them. Centralized error handling. Consider creating a centralized error handling procedure that can be called from multiple stored procedures. Code example. Explanation. The try, catch block handles any exceptions that occur during the insertion of the order. If an error occurs, the transaction is rolled back to prevent data corruption. The error information is logged to the TBL error log table using the built-in error functions, error_number, error_message, etc. The error is re-raised using throw so that the calling application can handle it. You can use try_convert to validate data types. For example, 6. Code formatting and comments. Why they matter. Consistent code formatting and clear comments make your code easier to read, understand, and maintain. Good formatting reduces visual clutter and helps you quickly identify the structure of the code. Comments explain the purpose of the code and how it works. Principles. Indentation. Use consistent indentation to show the structure of the code, example 4 spaces or 1 tab. Line breaks. Break long lines of code into multiple lines for readability. Capitalization. Use consistent capitalization for keywords and object names. Comments. Explain the purpose of complex code blocks. Document the parameters and return values of stored procedures and functions. Explain any assumptions or dependencies. Keep comments up to date. Use with eSpace. Use with eSpace to separate operators, keywords, and other elements of the code. Avoid excessive comments. Don't comment on obvious code. Focus on explaining the why rather than the what. Code example. Explanation. Indentation is used to show the structure of the code within the stored procedure. Comments explain the purpose of the stored procedure and the parameters. With eSpace is used to separate operators and keywords. Comments are used sparingly to explain complex logic. 7. Transaction management. Why they matter. Transactions are fundamental for ensuring data integrity and consistency in a database. A transaction is a sequence of operations that are treated as a single unit of work. Either all operations within the transaction succeed, or none of them do. Atomicity. Principles. Use explicit transactions. Always use explicit transactions, using begin transaction, commit transaction, and rollback transaction, when you need to group multiple DML, data manipulation language, operations, example insert, update, delete, into a single atomic unit. Asterisk minimize transaction duration. Asterisk keep transactions as short as possible to minimize locking and contention. Long-running transactions can block other operations and degrade performance. Asterisk handle errors correctly. Asterisk always include error handling within transactions using try, catch blocks. If an error occurs, roll back the transaction to prevent partial updates. Asterisk avoid holding transactions open unnecessarily. Asterisk don't start a transaction and then leave it open for a long period of time while waiting for user input or performing other non-database operations. Asterisk use appropriate isolation levels. Asterisk choose the appropriate transaction isolation level to balance data consistency and concurrency. The default isolation level is read committed, which provides a good balance for most applications. However, you may need to use higher isolation levels, example serializable, in certain cases where data consistency is critical. Understand the trade-offs involved: increased locking and reduced concurrency. Asterisk use set xact_abort on asterisk. The setting automatically rolls back the transaction if a runtime error occurs. It's generally a good practice to enable it. Asterisk isolation levels. Asterisk read uncommitted. Asterisk the lowest isolation level allows reading uncommitted data, dirty reads. Rarely used. Asterisk read committed. Asterisk the default isolation level prevents dirty reads by only allowing reading committed data. However, it can still allow non-repeatable reads and phantom reads. Asterisk repeatable read. Asterisk prevents dirty reads and non-repeatable reads. However, it can still allow phantom reads. Asterisk serializable. Asterisk the highest isolation level prevents dirty reads, non-repeatable reads, and phantom reads. Provides the highest level of data consistency but can significantly reduce concurrency due to increased locking. Asterisk snapshot. Asterisk uses row versioning to provide a consistent view of the data. Requires enabling snapshot isolation at the database level. Asterisk code example. Asterisk explanation. Asterisk set xact_abort on, ensures that the transaction is automatically rolled back if a runtime error occurs. Asterisk the try, catch block handles any exceptions that occur during the transfer of funds. Asterisk if an error occurs, the transaction is rolled back to prevent partial updates. Asterisk the error is logged to the TBL error log table. Asterisk set transaction isolation level, demonstrates how to set the transaction isolation level. Remember to reset it to the default after the transaction is complete. Summary of Part 1. This concludes Part 1 of our SQL Server Development Best Practices series. We've covered fundamental aspects. Asterisk consistent naming conventions. Asterisk crucial for code readability and maintainability. Asterisk appropriate data types. Asterisk optimize storage and prevent data errors. Asterisk strategic indexing. Asterisk improve query performance. Asterisk stored procedures and parameterization. Asterisk enhance security, performance, and maintainability. Asterisk comprehensive error handling. Asterisk prevent application crashes and provide meaningful error information. Asterisk clear code formatting and comments. Asterisk improve code readability. Asterisk transaction management. Asterisk ensuring data integrity through ACID properties. Remember that adopting these practices consistently will significantly improve the quality and reliability of your SQL Server applications. Next part will continue with more advanced topics like query optimization, security best practices, and performance tuning.